Good morning students, I am Balreddy, your physics teacher. Now present we discuss about electric potential and electric current. We know that for the flow of heat, it requires temperature difference. Like for the flow of fluid, it requires pressure difference. For the flow of air, it requires pressure difference. Similarly, for the flow of electric charge, it requires potential difference. And due to the potential difference, the charge flows from one place to another place, and that amount of charge flowing per second is called electric current. And to produce electric current, we require potential difference. First of all, we know what is electric potential and what is potential difference. How charge flows due to potential difference. First, it is electric potential. Electric potential ante the amount of work done in moving unit positive charge from infinite distance to a particular point in the electric field is called electric potential at that point. Electric potential at that point. Now let us consider a positive charge. Let us consider a positive charge body. Around that positive charge body, the electric field is produced. Now we want to find out the electric potential at this point. So the electric potential, according to the definition of electric potential, the amount of work done in moving unit positive charge from infinite distance to a particular point. Here infinite distance means అంటే అది అనంత దూరం అని కాదమ్మా. ఎక్కడైతే ఎలక్ట్రిక్ ఫీల్డ్ ఎండ్ అవుతుందో దాని తర్వాత ఉండే డిస్టెన్స్ అంతటిని మనం ఇన్ఫినైట్ గా వచ్చేసి తీసుకోవచ్చు. Now, in order to move that charge from infinite distance to a particular point, we have to perform some work. The work అనేది జరుగుతుంది. Suppose W is the work done in moving the charge Q from infinite distance to a particular point in the electric field. Then the electric potential, from the definition, electric potential V equal to W by Q. This means amount of work done in moving unit positive charge from infinite distance to a particular point in the electric field is called electric potential at that point. Here the electric potential around the charge carrier is not constant. It changes with the distance. It is having some electric potential. It is having another electric potential. It is another electric potential. And the units is work. Units is joule. Charge is coulomb. Joule per coulomb. Or another unit is volt. Volt is the SI unit of electric potential, which is defined as if 1 joule of work is to be done in moving 1 coulomb of charge from infinite distance to a particular point in the electric field, then the electric potential is said to be 1 volt at that point. Now, with that, suppose if there is one positive charge carrier, in order to move unit positive charge carrier, we have to perform some work. So it is having some potential. Suppose if you take two positive charge carriers, then repulsive force between them increases. Whenever the repulsive force increases, we have to perform more work. As we perform more work, electric potential increases. Again, if we add some another positive charge carrier, now again repulsive force increases more, so we have to perform still more work. The electric potential increases, and with the increase of positive charge, the electric potential increases. With the increase of positive charge, electric potential increases. Now, suppose if we take negative charge. Now, again, around the negative charge, electric field is produced. To find the electric potential at any point, from the definition, the amount of work done in moving unit positive charge from infinite distance to a particular point is called electric potential at that point. Suppose if we, ఈ unit positive charge carrier ఇక్కడికి తీసుకొని రావడానికి we are doing some work and it is having some potential. Now we take another negative charge carrier. ఇప్పుడు ఏమవుతుందంటే the force of attraction increases. Force of attraction పెరుగుతుంది. As the force of attraction increases, the force that we apply to move the charge carrier decreases. Automatically, work done decreases. As the work done decreases, electric potential decreases. And with the increase of negative charge, electric potential decreases. Now, if we add one more negative charge, ఇంకొక నెగటివ్ ఛార్జ్ యాడ్ చేస్తే అగైన్ అట్రాక్టివ్ ఫోర్స్ పెరుగుతుంది కాబట్టి amount of work done తగ్గుతుంది, automatically electric potential decrease అవుతుంది. అంటే with the increase of negative charge, electric potential decreases. Whereas with the increase of positive charge, electric potential increases. Positive, if you take a positively charged body, means it is, we say that it is at high potential. If you take a negatively charged body, we say that it is negatively, it is having low potential. It is having low potential. Now, how the charge flows? Due to the potential difference. Due to the potential difference. Okay, now let us consider that there are 4 positive charge carriers in one region and 2 positive charge carriers in another region. Now, more positive charge carriers means high potential, less charge carrier, positive charge carriers means low potential. And there exists potential difference between these 2 regions, between these 2 points. According to diffusion concept, the particles always flows from high concentration region to low concentration region. Diffusion concept ప్రకారం particles ఏవైనా కావచ్చు, ఎక్కువ ఉండే చోటు నుంచి తక్కువ ఉండే చోటుకి వచ్చేసి ఫ్లో అవుతాయి. సో the charge move from high concentration region to low concentration region. In terms of potential, how can we say that? Here, due to the potential difference, the positive charge flows from high potential to low potential. Along with that, there are equal number of positive charge carriers. From diffusion concept, the concentration is the same. So, there is no transfer of particles between them. And in terms of potential difference, we say that as there is no potential difference, here also same charge, here also same charge, so potential is same. So, there is no potential difference, so charge is not flowing. But in the earlier case, due to the potential difference, positive charge flows from high potential to low potential. Similarly, we take, there are 4 number of negative charge carriers, here there are 2 number of negative charge carriers, here there are more number of charge carriers, means it is low potential. Negative charge ఎక్కువ ఉందంటే low potential. There are less number of negative charge particles, so it is having high potential. But there exists potential difference between them. Again, according to diffusion concept, the charge carriers, their particles flows from high concentration region to low concentration region. ఎక్కువ ఉండే చోటు నుంచి తక్కువ ఉండే చోటుకి వెళ్తాయి. అంటే in terms of potential difference అంటే due to the potential difference, the negatively charged carriers flows from low potential to high potential. Low potential to high potential. అలా కాకుండా if the charge carriers are same, and we have same line కొనమా, there is no potential difference. Automatically there is no flow of charge carriers between them. Like this, for the flow of charge carriers, it requires potential difference. And remember one thing, the positive charge carriers always flows from high potential to low potential, whereas the negative charge carriers flows from low potential to high potential. Low potential to high potential. Now what is potential difference? This is around charge carrier. Now if we take 2 points in the electric field, now at this point the electric field having some potential V1 and it is having some potential V2. The difference between these two gives the potential difference, which is defined as, which is equal to the amount of work done in moving unit positive charge from one point to another point in the electric field gives the potential difference between the 2 points. Potential difference between the 2 points. Suppose W is the amount of work done in moving the charge Q between 2 points. Then electric potential difference P equal to W by Q. W equal to work done, force into displacement. Suppose L is the distance between 2 points. Then work done will become FL by Q. And the units are same. Work done is joule by charge which is coulomb, or other unit is volt, and the unit is volt. Now, that is about potential difference. Now we take the electric current. Electric current. Now we know that if we take the metallic conductors like iron, copper, silver, etc., there are 1 free electron for each atom. And in the metals, there are free electrons inside the metal. These free electrons are randomly moving in all directions with all possible velocities. And when there is no external electric field ఏది లేనప్పుడు these free electrons are randomly moving in all and the net flow of charge in any particular direction is 0. Now when the two ends of the conductors are connected to opposite terminals of battery or cell, we know that cell, it consists of two metal plates. One plate is positively charged plate, the other plate is negatively charged plate. We know that positive charge undi ante that is at high potential and negative charge undi ante it is at low potential. That means the cell provide the potential difference just కలిగేస్తాము. Now when the two ends of the wires are connected to the cell, now this end is at high potential and this end is at low potential. ఇక్కడ పాజిటివ్ చార్జ్ ఎక్కువ ఉంది, ఇక్కడ నెగిటివ్ చార్జ్ ఎక్కువ ఉంది కాబట్టి చార్జ్ చుట్టూ ఏమి ఏర్పడుతుందా, ఎలక్ట్రిక్ ఫీల్డ్ అనేది ఏర్పడుతుంది. అంటే ఏ యూనిఫామ్ ఎలక్ట్రిక్ ఫీల్డ్ ఈస్ ప్రొడ్యూస్డ్ త్రూ అవుట్ ద కండక్టర్ whenever the ends of the wires are connected to opposite terminals of cell. A uniform electric field is produced throughout the conductor. This electric field exerts force on the charge carriers. Due to that force, all the charge carriers are moved in one direction. ఒక డైరెక్షన్ లో వచ్చేసి పోతుంది. అది in terms of potential difference అని చెప్తున్నామంటే we say that whenever the two ends of the wires are connected to battery, the electron, due to the potential difference, the electrons, free electrons always flows from low potential to high potential. Low potential to high potential. And all the charge carriers are moving in a particular direction. And there is some resultant flow of charge in a particular direction. That amount of charge flowing per second through any cross section is called electric current. The amount of charge flowing per second through any cross section is called electric current. Let Q is the amount of charge flowing per second, flowing in a time t. Then electric current I equal to Q by T. And the SI unit of electric current is charge, which is weight కొలుస్తాం అంటే coulombs కొలుస్తాం, time వచ్చేసి seconds లో కొలుస్తాం. So coulomb per second is the SI unit of electric current. The other unit of electric current is ampere. If 1 coulomb of charge flowing through any cross section per 1 second, then the electric current is going to be 1 ampere. అంటే ఒక సెకండ్ కి ఒక కూలంబ్ ఛార్జ్ అంటే ఎన్ని ఎలక్ట్రాన్స్ అమ్మా, 6.25 into 10 to the power 18 electrons flow అయితే then we say that electric current is going to be 1 ampere. Electric current is going to be 1 ampere.